easily take us the whole period, but I would like you to stop me with 10 minutes left if you have some questions for the homework check tomorrow. Do some of you have questions for tomorrow's homework check? Yes, Faisal said yes. Okay, so with 10 minutes left, tell me to stop and we'll finish anything we need to tomorrow, okay? All right, here we go. We reviewed yesterday the fact that we could graph things in our, I don't have a pen, here we go, our theta form on the circle graph paper, remember? And we did things like maybe 45 degrees, radius 3 would be out there. Okay. That point also has a name in the XY coordinate. That's going to be what we're doing today, is switching back and forth between these. This distance is 3. Any ideas how we could find the X and the Y? Sine and cosine. Does this sound familiar? Should sound real familiar from vectors, right? That's how we're going to change things given this form into an X and a Y. But we're also going to be given an X and a Y today, like over here at 2, 4, and we're going to have to find, this would be 2, this would be 4, we're going to have to find the R and the theta. Any ideas on that? Pythagorean theorem and inverse tangent. Okay, so right there is everything you need to know for today. Then we're going to get into equations though, and we're going to use those same trades, but it's very uncomfortable because it's hard to know which trade to use. So I'm going to show you some examples, but what I need you to get out of this today is that the questions on that kind of stuff are all going to be multiple choice on the quiz. So if you can graph it and figure out the equation a different way by trying the choices, you'll be okay. All right, I want to show you this. It's a really good thing to learn, but I am not going to make it hard on a test. Crystal, this is for you for right now. I don't know when you want to go, though. Not now. Okay. I'm not going to spend a lot of time on this slide, other than to say this looks familiar. Cosine is x over r, so x is r cosine theta, and r sine theta is y. Okay? Those are the conversions we're going to use. So did we not just write that on the last slide? We are so smart. Okay. And I'm going to skip to this example, and then we'll talk about going the other way. This is an r and a theta in radians. The trick is they want us to do as many of these as possible in exact form. So instead of saying 3 cosine 3 pi over 4 and 3 sine 3 pi over 4, now we're going to look at our unit circle and find the cosine and sine. Does that seem okay? So the cosine at 3 pi over 4 is negative square root of 2 over 2. Got your unit circle out? The sine is positive square root of 2 over 2. So the rectangular coordinates in exact form are negative 3 square root of 2 over 2 and positive 3 square root of 2 over 2. Okay? We're going to try these. We're going to use our unit circle. We're not going to use our calculator, so it doesn't matter degrees or radians. This is going to be r times the cosine and r times the sine. Okay, looking at our unit circle, this is going to become our x and our y here. Looking at our unit circle, what is the cosine at negative 60 degrees? Everybody okay? Do you need me to pull a unit circle up on here so we can talk about that again, or you just find 300 and give me the x value, right? And then this one would be the y value. Did I get that one right? So how is that going to simplify? Half of 20 is 10, And half of 20 square roots here, we're going to have negative 10 square roots of 3. Okay. Revisit your geometry self. Does over 10 down 10 square roots of 3 out 20 and 60 degrees look like a special right triangle that should work? Okay. This is very uncomfortable for us because r is negative. Let's just try it and see what happens, okay? So we're going to say r cosine of 5 pi over 6 will be negative 1 times cosine at 5 pi over 6. Somebody? Okay. And r times the sine at 5 pi over 6 will be negative 1 times positive 1/2. What's that become? Positive and negative, yes? Okay. I need you to visualize for me your circly paper. On your circly paper, if we went around 5 pi over 6 and then we backed up 1, right? Would we be over here in this fourth quadrant? Is that where square root of 3 over 2 negative 1/2 wound up? So it seems okay that even though we had an r negative, it worked out. Okay. Can you try these two then? Inexact answers? Well, I make up one that won't work as exact over here. How did I do on the first one? Did we get the first one right? And then I just got a messy 3/2 and 3 square roots of 3 over 2. Did someone else get that for the second one? Okay. Anybody confused? Did you figure out what you did, Ben?
Yeah, I was reading number 4 to number 3. I'm like, whoa, what the
Oh,
hell is wrong?
gotcha.
Yeah. Okay.
Nope, this is 3. This one is 4. We okay? All right, this is an example of a question. Is that going to be on our unit circle? No. So you would put your calculator in what mode for my example? Degrees. And then you would type 5 cosine 22 and 5 sine 22 and get some decimals. Got to be in degrees. I don't think we're going to get negatives. I got 4.6 and 1.9. Anybody? I rounded, but I was just making up an example. There's some in the book. You want to do as many of as you can using the unit circle, okay? I'll just leave it at that. If you can't use the unit circle because it's not on your unit circle, then you're just going to type it in. I don't remember if they gave you any in radians that you can't use the unit circle for. It's possible, I suppose. All right. The other direction, okay? The other direction is when we're given what were we given? I'm so confused. We were given an r theta. Now we're going to be given an x, y, and we're going to want to find the r theta. So given an x and a y, remember we talked about this, we're going to do, to find r, we'll do the square root of x squared plus y squared, yes? Pythagorean theorem. And then we'll do inverse tangent to find the angle. The trick is, if we have a negative, we're going to have to add 180 or pi to it. So There's a little chart here, but I'm not going to talk so much about this. This is a kind of icky example. I'm going to do it in degrees first because I think it'll make sense to you in degrees, and then we'll do it the way they want us to in radians. Everybody okay? So we're going to talk about this point, 5, negative 9. Over 5, down 9. I need to find that as an r theta in a polar form. So first of all, I do 5 squared, 9 squared. I get square root of 106, or 10.3. Everybody okay? Where we got that? That's our r. If I wanted this angle in degrees, what would I do? Inverse tangent of opposite over adjacent, or y over x. In degrees, what does that come out? Am I in degrees? I am in degrees. I'm just going to round to negative 61 degrees, okay? Did someone else get that? Okay. That's an answer. So we have square root of 106 is our r and negative 61. But do you remember in polar mode, every point has infinite names, remember? We need some more names for that. What could we do to get another name? We could add 360. We'd have 299. What else could we do? Remember the negative stuff? If we wanted to switch it across over here and say we backed up, we'd say I went this way and backed up 106. We do what? Add 180. Everybody okay? This is really important. This is the most important thing out of all this. To get straight across so you can back up, you would add 180, right? So negative 61 plus 180 is 119. Okay. These are the two that they're probably going to want eventually. Actually, they didn't. They left one of them negative. Okay. We're going to do the question over again in radians. We still do Pythagorean theorem and get square root of 106, yes? Which is 10.3. Then we're going to put our calculator in radian mode and then do inverse tangent of negative 9/5. Okay, change the mode on your calculator. Inverse tangent, negative 9/5. Negative 1.06 radians. Okay, that's one answer. We could add 360, or not 360. What would we have to add? 2 pi to get another answer. But what's the answer straight across? The one where we had to back up? 10.3. Instead of adding 180, what are we going to add? Pi. So if we added pi to that, we got 2.08 roughly. Now that's in radians and it's kind of hard for us to think about. Okay? But if you rotate it around 2.08, which would be less than pi, right? And then you backed up 10, you'd be in that quadrant. All right, let's try a couple that aren't so icky. What mode do we have to do these in? Between 0 and 2 pi. We can't even use negatives for the angle. Okay, got to be in radians. I would like us to do the first one without a calculator at all. So if we go right 2 and down 2, what can you tell me about that magical triangle we just made? It's got a 90 here. These are the same, so it's 45, 45, 90. If you remember the rule, it's leg, leg, and leg square roots of 2. But if you don't, and you do Pythagorean theorem, you get square root of 8, which is 2 square roots of 2. So our r is going to be 2 square roots of 2. And what is our angle here in radians? Negative pi over 4. Is that going to work as an answer? That's supposed to be a negative pi. Kind of looks like a disaster there. Is that going to work as one of our answers? They're hating. Has it between 0 and 2 pi? We gave a negative answer. Look at your unit circle. What's another name for that? Good job. Okay. 1 down, 1 to go, because the directions say we need 2 answers. What's the other option? Think about that. Look at your unit circle. What could you do and then back up? 3 pi over 4, and then you would have to say, I'm going to back up how much? Negative 2 square roots of 2. That one work out for us? Okay. Is this one going to turn out nice? Positive 3, positive 5. Is that going to be anything on my unit circle? Nope. If I do Pythagorean theorem, I get 25 and 9 is 34. Okay. I'm just going to go ahead and use a decimal because the other answer is going to be decimals anyway. Square root of 34, 5.83. Anybody getting that? Okay. So I need 2 points, 5.83 comma something, and another one with a 5.83. We may need to make it negative though. Okay, how do we find the angle? Inverse tangent of what? 5/3. Good job. Inverse tangent of 5/3 in radian mode, because that's what they want. What do we get? 1.03. Does that seem okay? Less than pi over 2, right? Less than 91 radian is 57 degrees. I don't remember. Okay. So we're in the first quadrant. We're good. We need another name. If we added pi and said I'm going to go all the way around to here and then back up, this can be negative 5.83 and whatever that plus pi is, which is 4.17. All right. First one isn't bad, yes? First one isn't bad. Pythagorean theorem, inverse tangent. Second one is a little tricky. All right. Now I'm going to go through some stuff. You can put down your pencil and just watch for a second. We are going to change rectangular to polar. What can you tell me about this graph right there? It is a circle. The radius is 4 and the center is at 4, 0. Okay. Anybody remember how we graphed a circle in polar with a radius of 4? R equals 4 was a circle, right? It looked like this. Problem is the center wasn't at 4, 0, right? Okay. But R equals 4 is a circle. So it's going to be something in R equals form when we're done. And when we're done, we're going to graph it and check. All right. We're going to do these trades, and it's kind of miserable. Watch. We're going to trade X for R cosine theta. And we're going to trade Y for R sine theta. But we have to square them. R cosine theta minus 4 squared is R squared cosine squared minus 4R cosine theta minus another 4R cosine theta, which became minus 8R cosine theta. Negative 4 times negative 4 is 16. This one, R sine theta squared, is just R squared sine squared. And it was equals 16. Then they said, well, let's just knock this equals 16 out of here. Does that seem okay? All right. Then they decided to add this over to the other side so that they had this mess left. Because if they took out an R squared, guys, look what happened. Cosine squared plus sine squared is 1. Then they got to here, divided both sides by R, so they had R equals 8 cosine theta. Okay, I want everybody to be doing this. Calculator in radian mode. polar and radian. Window 0 to 2 pi. I'm going to go with negative 10 to 10 and negative 10 to 10. And I'm going to get an ellipse because I didn't do a square yet. I'm going to put in 8 cosine theta and graph. Doesn't look like a circle. How do I fix that? Zoom square. Okay, we said it should be a circle whose center is at 4, 0, whose radius is 4, so it should go out to what? 8. Does it look like it's going out to 8? You can turn the light off if you need to. Does somebody want to turn the light off so you can see it better? Does yours look okay on your screen, guys? All right. This one should be a what when I graph this? Y equals x squared is a line? It's a parabola that opens up, yes? Okay. That's not hard to graph. Unfortunately, it gets kind of messy. We're going to put in for y, r sine theta, and for x, r cosine theta, and then we're going to square it. Okay? We need to get r by itself, so we can divide out an r here. And then when we now have sine theta equals r cosine squared. I could divide both sides by cosine squared, so I get sine over cosine squared equals r. Is that something I could type in my calculator? Yes, actually, I could. They went ahead and said, this is a sine. I'd like to make sure you're paying attention here because this, when it's a multiple choice question, is not going to necessarily look how you want it to look. This is a sine over cosine, but there's another cosine on the bottom. Everybody okay with that? Sine over cosine is tangent, and 1 over cosine is secant. You thought those trades were gone for good, didn't you? Okay, do we have a secant button on our calculator, though? No, so we could do tangent divided by cosine, or tangent times 1 over cosine. You could actually do sine squared divided by cosine squared, and it would work. So we're trying to get it to graph this and make sure we got an equation that makes a what again? Parabola. So I'm going to do tan theta times, and I'm going to just go ahead and do 1 over cosine, because that was kind of how we had it originally. Does it make a parabola? Did it do it kind of weird? It started at the origin, and it was kind of rotating around. Think about that. Do you think, because we're in polar mode? So how it kind of, I don't think I can get it to do it again. I could do it with a little bouncy ball, maybe. We're wasting time. We shouldn't be wasting here, but. Goes around this way, and then it comes back that way because it's rotating as it goes. Okay. Yeah, and then it does it again. Okay. We're going to try these. Ready? What can we trade for x? Wait, what should this be? X equals 5 is? It has undefined slope. It is a line. What kind of line? Yeah, vertical line. Up and down. Vertical line. Okay. What are we going to trade this for? R cosine theta equals 5. But to be able to type it in our calculator, we're going to have to do what? Divide by cosine, so the r's by itself. That's what we're going to type in. But what do you think the book would actually write as a choice for that? 5 times 1 over cosine, which is secant. So the choice on a multiple choice might say this. Okay? But when we type it in, we can just do 5 divided by cosine because we don't have a secant button. So 5 divided by cosine. Did we get a vertical line out at 5? Yay, we are good. Okay. This one's going to be weird. Okay. Think about what this line looks like. Can you graph this line? Because I want to help you think of how you would do this on test or quiz, because you'd be kind of clueless at this point. And you'd go, well, y equals x is this line, y equals negative x means it has a negative slope going this way. Okay. Do you remember anything about how to graph a line like that? Remember we had r equals 2 was a circle of radius 2? Do you remember how we got a line? Did I not do one at the beginning? I don't remember. If you had like theta equals pi over 3, do you remember that was a line here at pi over 3 from last week? The week before? Okay, that's kind of what we're going to get to, is something with a theta. Can we graph that on our calculator? No. All right, so y is going to be r sine theta, and this is going to be negative r cosine theta. As soon as we divide out r, it's gone, right? We have sine theta equals negative cosine theta. Is that on your unit circle somewhere where the sine and cosine are the same but opposite signs? Okay, this is what I'm going to think of. I'm going to divide both sides by cosine. Because what's sine over cosine? And what's cosine over cosine with a negative? Negative 1. Where's the tangent negative 1? 3 pi over 4. Where else? Could I call it negative pi over 4? Could I call it 7 pi over 4? Would any one of those make... That's an example from another question. I got to erase that so you're not confused. But would any one of those make this line? 3 pi over 4, negative pi over 4, 7 pi over 4, all points on that line? Okay. This means I rotate 3 pi over 4, and I don't know what the radius is, so I have to include every radius possible. Or I rotate negative pi over 4, and I have to include every radius possible. Does that help? Yeah, it divided out. You can't graph these on the calculator. Yep, only in rectangular form. Like I said, this would be a multiple choice question if it was on there. I don't think it's going to be on there anyway like that. All right, let's try this one, guys. What's going on? Yeah, this is a circle, right? So when we're all done, we want it to be a circle whose center is at 0, 3, and radius is 3. So it should look over 0 up 3, radius of 3. It should look like that, yes? Okay. Can I actually graph this in function mode? Not very easily, because it has to be in y equals form, right? Yeah, big old mess. Okay, but we're going to replace this with r cosine, and we're going to square it. And this is going to be r sine theta minus 3 squared equals 9. Remember, cosine theta is all one function, right? So when we square it, we just get a cosine squared. It doesn't square the theta. So it's r squared cosine squared theta. This one, do you need me to write out? R sine theta minus 3 times r sine theta minus 3. What's that going to become? R squared sine squared. Then what? Minus 6. Good job. R sine thetas. And a negative 3 times a negative 3 is? Plus 9 equals, and there was a 9 on the other side from right there. Okay. What can we do then? We can subtract off the 9 and we have a 0. Ideas? Do you remember the trick? We add this over to the other side. And on this side we'll be able to take out the r squared. Can I just write it once? Then twice. Okay. Cosine squared plus sine squared is 1. So I have r squared equals 6r sine theta. Then what? Divide by an r, and we just get r equals 6 sine theta. Let's try it. Look like the radius is 3. It's up at 0, 3 for the center. The diameter would be 6 then. Seem okay? I could trace and see if we went to 6 up here. We should get somewhere close to 6, 0. Okay. I could put it in r theta, and then I could pick my r. That was miserable. But if I had a bunch of choices, could I type them in my calculator and figure out which one made the right circle? Oh, okay, just checking. All right, this one would not be on a test or quiz. Let me go through this with you real fast. This is going to be r cosine of theta squared minus r sine of theta squared equals 1, which would be an r squared cosine squared minus an r squared sine squared equals 1. If I take an r squared out, okay, cosine squared plus sine squared is not 1. Or is 1. Minus is not. I think I said it wrong. Okay, can you find that though? Aubrey's looking. She remembered. There's one with a cosine squared minus sine squared. What's the trade? This is a cosine of 2 theta. Now, is that something I could type in my calculator? Cosine of 2 theta? Okay. So I have r squared times cosine of 2 theta equals 1. Ew. There's no pretty way to do this. We need the r by itself, so we're going to divide and then square root. So we get r equals, square root of 1 is just 1, right? Over the square root of cosine 2 theta. Can't do anything with it. I'm going to type it in. R equals 1 divided by the square root. Not the matrix, Hofbauer. Square root of the cosine of 2 theta. Yeah. I didn't remember to ask you at the beginning what this should be. This is what I'm graphing. Okay, but it was originally x squared minus y squared equals 1. I forgot to ask you for a prediction. It should be a hyperbola whose little rectangle is really just a 1 by 1 square. And then it should be going which way? Side to side because it had x's. So this is what we should be getting. Now, it's very hard to tell on here. If I make the window... It's complicated. It has to do with the pixels, guys. If I make this like -5 to 5 and -5 to 5, did you notice it did quadrant 1 and then it did quadrant 2 and then it did quadrant 3 and then it did quadrant 4? The reason, does everybody's kind of just, it kind of cuts off? The reason is it's a curve, right? A hyperbola is a curve, and the only way it could continue it on, it would look straight. And it wants you not to be confused and think that it suddenly becomes straight. That has to do with the pixels. All right. Go in the other direction. Ugh. Almost need a second candy break today. This is so intense. Ready? Go in the other direction. This is a what? Visualize all the points, no matter what the radius, that has a theta of pi over 6. It's a line. Okay. What we have to do, though, is weird. We have to take the tangent of both sides. So we have the tangent of theta equals...
10 minutes.
What? There's like 20 minutes left. Oh, we get out at 20. You're right. Okay. You're right. 40. Yep. 40. 22. Gotcha. We're getting there. Okay. Shh. Tangent pi over 6. Tangent pi over 6 is a value I can put in. It's square root of 3 over 3 when I look at my unit circle. And tangent is y over x, yes? So then I multiply the x over and I get square root of 3 over 3. It's icky. This one is way easier. If I square both sides, I get r squared equals 49, and r squared is x squared plus y squared, because it should just be a circle, right? All right. And this one, watch. We're going to multiply an r onto both sides so that I have r squared equals negative 5r sine theta. What am I going to replace r squared with? X squared plus y squared. And what am I going to replace over here? It's going to be negative 5y. So I would accept x squared plus y squared plus 5y equals 0. They actually completed the square and got this form, which made the center here and the radius so that they could check the graph worked, okay? We're going to try these real quick. What are we going to do here? Square both sides. Great plan. So we have r squared equals 16. X squared plus y squared equals 16. Now, how many of you could have figured that out just if it was multiple choice, that this was a circle of radius 4 and this was a circle of radius 4? Some of you, maybe? Okay, r sine theta. Yes? R sine theta is just y. If we wanted to check it in polars, we could divide 4 divided by sine theta and see what we get. What is that? Should be a horizontal line, yes? There we go. Do you remember what this one we had to do? Tangent of both sides. Tangent at pi over 3, anybody? It's just the square root of 3 over 1. And tangent by definition is y over x. And to get the y by itself, last one for today. Then we're going to save the rest for warm up tomorrow. We're going to have to multiply what onto both sides? Multiply an r onto both sides, which will make it r squared equals 3r cosine theta, which becomes what? X squared plus y squared equals 3x. All right. On your test, it would probably say x squared minus 3x plus y squared equals 0. I'm going to super fast complete the square. You'd have x squared minus 3x plus blank plus y squared equals 0 plus blank. This would be x minus 3 halves squared should be 9/4. What's 3 halves, guys? Okay, 1.5, 0 should be the center. The radius is the square root of this, which is 1.5. What's 1.5 plus 1.5? So the diameter should be 3. Okay. Checking it out. 3 cosine theta. 3 cosine theta. Is that a circle? I got to do a zoom square. Mine's not looking like a circle. Is that a circle whose center is at 1.5 and goes out to 3, a diameter of 3? Okay. Stop recording. We will pick up with